All right, guys, welcome to the Unit 3 study guide. Key. Your test is on Friday. Graphing calculators are allowed. It's 40 minutes. I have office hours on Friday morning if you have any last minute questions. All right, let's get started. So, given the following polynomial function, f of x equals negative 7x to the fifth plus 4x to the fourth minus 3x to the third plus x minus 15, what is the leading coefficient? So, the leading coefficient again is that coefficient of the highest degree term, which is x to the fifth, so that's going to be negative 7. The degree is going to be 5 because it is the highest power, so degree is 5. It has at most how many extrema? So there are n minus 1 extrema max, which means that there must be 4 maximum. And how many zeros it has? It has 5 zeros. Okay. Because of that. Describe the end behavior of this polynomial based on, and explain why based on a characteristics of the function. So we know because this is negative, it's going to end with y approaching negative infinity because the leading coefficient is negative. And as y approaches negative infinity, y is going to approach infinity because the degree is odd. And if you had some overlap in your explanation, like you included both of these at once, that's fine. Okay, given the following equation, x squared plus 10x minus 6, complete the square and rewrite the equation in vertex form. So to complete the square, we want to add and subtract what would make this a perfect square. So your b over 2 here is 5, and 5 squared is 25. So we're going to add 25 here, and then we're going to subtract 25 there. And then we're going to rewrite this as x plus 5 squared minus 31. So the vertex would be negative 5, negative 31. Okay? All right. Question 3. Given the following function, determine the following features. So yes, you can use a graphing calculator, but you want to be able to reason without one. Okay? So the value of the y-intercept. So to find the y-intercept, we're going to find f of 0, which just means plugging in 0 for everything. So we have 3, negative 2, and 4 divided by negative 2 and negative 3. That will be 12. This will be negative 4. So my y-intercept is 0, negative 4. Okay? X-intercept. So when we find the x-intercepts, you're setting the numerator equal to 0. So numerator equal to 0, but no holes. So don't include any holes. So the numerator would be x plus 3, x plus 4. We're going to set that equal to 0. So it'll be x equals negative 3 and x equals negative 4. No holes. Okay. X equals negative 3, x equals negative 4. Vertical asymptotes. So vertical asymptotes is 0 only in the denominator. And that would be at x equals 3. Horizontal asymptotes. You check the degrees. So again, if the degree of top is bigger than the bottom, there's no horizontal asymptote. If they're the same, you divide the leading coefficients. And if the bottom is bigger, the horizontal asymptote is 0. So here the degree of the top is 3. The degree of the bottom is 2, so there is no horizontal asymptote. Because the degree of the numerator is greater than degree of denominator. Okay? Slant asymptote. To find the slant asymptote, you divide the numerator by the denominator. So because we can cancel out the x minus 2, we can just write it as x plus 3 times x plus 4 divided by x minus 3. It's the same as x squared plus 7x plus 12 over x minus 3. We do some long division. X squared plus 7x plus 12, x minus 3, it's x squared minus 3x, subtract, we have 10x plus 12, so this would be a plus 10, and we're done there. Okay, this right here is my slant, asymptote, the quotient, okay? Whole, so whole is where 0 is in the numerator and denominator, that is going to be x equals 2. So to find the coordinate though, it's going to be 2, and then we're going to plug it back into this, but we're going to plug it back into what's left after we cancel the whole out. So what's left is x plus 3, x plus 4 over x minus 3. We'll plug a 2 into that. 5 times 6 over negative 1, which is negative 30. So 2, negative 30 would be my whole. Okay? All right, question 4. Given the following equation, identify all possible rational roots. So again, this is factors of constant divided by factors of leading coefficient. So that would be plus minus 4, plus minus 2, plus minus 1 over plus minus 1. So that's plus minus 4, plus minus 2, and plus minus 1. Okay? So then we would use the graphing calculator. Let's do it here. And we'll do x to the 4th plus x to the 3rd. My bad. Minus 5x squared minus x plus 4. Oh, can you see that? There it is. And we can go to the table and we'll plug in those roots. So 1, negative 1, 4, 1, negative 2, 2, and 4. And we can see the zeros are going to be 1 and negative 1. Okay, so my real zeros, because f of 1 equals 0 and f of negative 1 equals 0, then it's x equals 1 and negative 1 are my real rational roots. Then we use synthetic division or long division to divide the polynomial by the rational roots to identify any irrational or imaginary roots. So what that means is we take our polynomial 1, 1, negative 5, negative 1, and 4, and divide that by 1. The 1 drops down, 1 times 1 is 1, add it 2, 2 times 1 is 2, negative 5 plus 2 is negative 3, negative 3 times 1 is negative 3, add them, negative 4, and 0. So the new polynomial is x to the 3rd plus 2x squared minus 3x minus 4. Synthetic division again. 1, 2, negative 3, negative 4, divided by negative 1. 1 drops down, negative 1, 1, negative 1, negative 4, 4, 0. So it's x squared plus x minus 4. Then from this point, you're going to use quadratic formula to solve this. So it's going to be negative 1 plus or minus the square root of negative b plus or minus square root of b squared. 1 minus 4ac, so plus 16, yeah, over 2. So you get negative 1 plus minus root 17 over 2. These are your last two roots. So in total, your roots are x equals 1, x equals negative 1, x equals negative 1 plus root 17 over 2, and x equals negative 1 minus root 17 over 2. Okay, those would be your 4 zeros. So when you graph them, it's just here, here. I mean, we can graph it. And see roughly like this, and roughly like, well, roughly like this. Okay, this isn't perfect. Okay, but ignore the scale for a second. This is going to be, these are my 4 x-intercepts here. Okay. Okay, last page. Given the following equation, we're given that 2i is 0 of the above function from the remaining roots. So you have your calculator, so you're probably tempted to jump in your calculator. So let's do that. X to the 4th plus 2x to the 3rd. Plus 6x squared plus 8x plus 8. And you'll see it doesn't really look like we have any x-intercepts here, right? And if we like zoom out more, okay, this isn't a great representation, but it doesn't look like we have any. And we could even try our rational roots, which would be 8, negative 8, 4, negative 4, 2, negative 2, 1, negative 1. And you can see that none of these are zeros. See that? So I tried my rational roots. None of the rational roots are working, which means that's what's left in here, and it doesn't look like there's any x-intercepts anyway. So it looks like what's left in here are imaginary. So you know that 2i is 0 because of the conjugate rule. Negative 2i also is a 0. So therefore, if we know that x equals 2i, we know that x equals negative 2i, and so our factors are going to be x plus 2i and x minus 2i. Follow me? So what we need to do is, since we know these are factors, we're going to divide this polynomial by these factors to get what's left over, to find what's remaining. Divided by imaginary numbers is not nice, so what we do is we're actually going to multiply these two together. When you multiply these two together, you're actually going to get x squared plus 4. Not too bad, right? And if you want like a refresher on that, you can do the box method, x 2i, x negative 2i, and when you multiply, you'll okay, x squared 2ix, negative 2ix, right, those cancel, and then you have negative 2i squared, which is just 4. So that's where you get x squared plus 4 from. So we're going to divide x to the 4th plus 2x to the 3rd plus 6x squared plus 8x plus 8 by x squared plus 4. So it's going to be x squared here, x to the 4th, we're going to put a 0x to the 3rd because there's nothing there, plus 4x squared. We're going to subtract all of that. We're going to get 0 here, we're going to get 2x to the 3rd here, we get 2x squared here, and we'll bring that down at 8x. Okay. X squared times what is 2x to the 3rd? That's just 2x. 2x times x squared is 2x to the 3rd. 2x times 4 is 8x, that'll be here, but there's no x squared, so 0x squared there, placeholder, right? Subtract all of that, you get 0, 2, 0, and then an 8 will drop down. X squared times 2 is 2x squared, so that goes there, we'll get 2x squared, and then an 8, and we're all good, we're all clear, we got zeros, which we should get, right? At the very end. Like if you're dividing by this and you're getting a remainder, something went wrong. You shouldn't be getting a remainder if these two are factors. And if this is a factor, when you divide, no remainder. Anyway, so what's left over is x squared plus 2x plus 2, and we're going to use some quadratic formula to solve this. So it'll be negative 2 plus or minus the square root of 4 minus 4/8 minus 8 all over 2. What is that? Well, that's the same as negative 2 plus or minus root negative 4 over 2. That's the same as, move it, negative 2 plus or minus 2i over 2. And that's the same as negative 1 plus or minus I. Those are our last two roots. So up here we'd have x equals negative 1 plus I, and x equals negative 1 minus I. So my last factors would be x minus negative 1 plus I, and x minus negative 1 minus I. Okay. All right. Last part here. So this is something that you need to be prepared for. So be prepared to write a function given a description. So this could be a polynomial like this, or it could also be a rational function like this. You know, it could also be a rational function. It could also tell you, instead of, basically I could give you some of this, and then I could ask for this. Okay, so just be prepared for that. Let's look at this though. We're told that it's always positive. If it's always positive, that means we gotta have even multiplicity. Okay, because it can never cross the x-axis. That means even multiplicity. I'll talk about that in a second. We also know that we're gonna have a 0 at 3 and a 0 at 6. So okay, that means x minus 3 must be there and x minus 6. We also know that these need to be even multiplicities. We also know that the degree is 8. We also know the leading coefficient is 3. The 3 can just be put out front. That's easy. We also have one imaginary root. There's at least one. You can have more than one if you wanted one. But we can write this as something like just x minus I and x plus I, because that's like the simplest imaginary root, right? But so this is looking pretty good. The problem right now is that this is going to cross the x-axis, which I don't want, and the degree is not 8, which I also don't like. So in order to counter this, we're going to put this to the power of 2, this to the power of 2, this to the power of 2, and this to the power of 2. And that's going to get us to a degree of 8. It's also going to mean that we're not going to cross the x-axis because the multiplicity is 2. So meaning it's going to bounce there. If it's even multiplicity, it bounces, right? And so we're good to go. So roughly what this will look like is a 3 here and a 6 here. Roughly speaking, this is not a perfect science. It's going to look something like this. Okay, it's not perfect, but it'll look crazy in reality because of the size of the degree here. But it's going to look roughly like this, and it will always be positive, and that's fine. Okay. And that is a practice test. So yeah, that's a pretty good representation of what you can expect. Be familiar with each section. Look over the review sheet, and come to office hours. All right. See you guys.